So we're going to talk about two of Kahn's most important buildings, medical towers and Salk. So all you have to write down is medical towers. It's the A.N. Richards Medical Research Laboratory and University of Pennsylvania, yada, yada, yada. We're going to call it the medical towers. So that's good enough for us. And this is what they look like. There are two parts of the building. We're only going to talk about one part of it. And this is a very striking image at the time. A lot of buildings look like this now, particularly built through the 1970s and 80s on university campuses. But at the time, it was in stark contrast to Mies van der Rohe's Seagram Building. So Seagram Building is 1958, and Kahn's Medical Towers, or Richards, is 57 to 61. So they're around the same time. And this is not the first glass skyscraper. The first one is 1953, the Lever Building, went diagonally across the street. But this was sort of the icon of the glass skyscraper. Now, in a radio interview, Kahn said something about this building, pardon the language, but he said, the Seagram Building is like a beautiful woman in a corset. You want to let the shape hang out. In other words, this building has stairs, elevators, diagonal bracing, shear walls, air conditioning ducts, plumbing, wiring. Where is it all? Modern architecture had promoted itself as being honest. You know, it's going to show you how the building's really built, unlike those Beaux-Arts buildings, which were, sticking columns on and hiding the structure. Well, this is hiding the structure. Actually, you can see the columns down here, and they just a little bit show through the glass, but Mies puts the curtain wall in front of the structure. Now, what we're going to do as we go through this building is we're going to see this is not just a bunch of arbitrary form. Let's put some bumps on the building to make it more interesting. No, that's not what Kahn's doing. Everything we see here is there for a reason, and we'll see what those reasons are as we go. So here's a plan of the Seagram Building, and of course Mies wants this open, flexible loft office space. That's what a office building needs. Each tenant comes in and says, here's what I need. And you come in and you build out the space according to your needs, and then that gets ripped out unless the next tenant wants to keep what you did. In Kahn's case, here are all this elevators, fire stairs, bathrooms. Kahn puts all that in here, puts his open flexible space here, and then puts his additional ducts and stairs here. So there's a reason to this. So again, here's the building. Does anybody tell me what this is? That's a column. This is stairs, this is ducts. So stairs and ducts, you'd have to know the trick to know which is which. But this is structure, this is mechanical. And he wants to distinguish between them. So let's start the way we should in architecture with sort of pinning down where our building is located. This is Central City, Philadelphia, Broad Street, Market Street, Penn's 5 Squares, Delaware River, Schuylkill River. So here's that Schuylkill River. University of Pennsylvania is right here in West Philadelphia, so here we are. Here's an old dormitory. Here is Penn Hospital, the medical school, the biology building, and then here is this lavatory between the medical school and the biology building. This is a walkway between the dorm and these medical buildings. So now we have a sense of, context of where it's located. So here's the pathway between the dorm and medical towers. Here we are in the quad of the dorm, seeing the brick of Kahn's building sticking up and responding to the brick of the dorm. There's a rule at the University of Pennsylvania, all buildings have to have brick. None of the brick here is structural, it's all veneer, except for these exterior walls here. But this is poured in place concrete with a brick veneer on it, but that's what you had to do. And Kahn's going to respond to this. He didn't like the way that turned out. He's going to respond to it later. Now, here's the medical towers, here's the biology building. We're not going to talk about this. So here it is on the model. We're going to talk about this cluster here, which is this. Can anybody tell me why there's two plans in this drawing? Typical floor, ground floor. So typical floors 2 through 7 are all the same, very similar. And the ground floor, he knocks out one of the pavilions. There's a glass wall around here. There's no wall around it at the bottom. And that becomes the entrance. Stairs up and then the doors right here. Same thing over here. You can see he's left out the walls and this becomes an entrance pavilion. Now, I should have gotten a typical floor, but here's a plan of a ground floor. Let's pretend it's a typical floor. And let's see what we have here. We see all this articulation. Things, he's telling us this is this, this is this. Let's see what all this is and why it's arranged this way. And Kahn begins, now we're going to get theoretical, and we'll spend some time on theory. Kahn begins with, what is science? Kahn begins every building with the question, what does this building want to be? And so let's say we're doing a school, and so let's, it's almost a cliche. Well, school should be a place where it's good to learn. Okay, but now, what is learning? I'm on a jury, and I'm looking at your school. Is your position that the job of school is to prepare people to become part of their society? Or is the job of the school to enable each individual to identify their own individual sense of who they are and manifest that? Two different theories. I'm not going to say which one is right, but if I'm on your jury, I want to know what your attitude toward education is. That's going to help me understand your school. So, Kahn says there's two parts to science. First, there's the measurable. There's measurement. Scientist works in an open, flexible space with where we can change the arrangements of lab tables in response to different experiments, doing experiments with, since it's biology, let's just say, test tubes, petri dishes, etc. And we don't want any structure in here, we don't want any elevators in here, we want this open, flexible space. And then he says, then there's the unmeasurable. The scientist goes to the light and reviews their notes. Says, what does this mean? And develops a theory about what they've done. And that is a cultural act. So let's just say we're Isaac Newton and we're dropping apples. So that's the law of gravity. So now we have general law. a generalized theory as a cultural notion done here, sitting at our desk, looking at our notes, looking out the window, contemplating the trees outside, after we have worked in here doing measurements. So that gives us this arrangement. Now, we need to hold this up. We need columns. He does not want to put any columns inside here because we want all this to be open, flexible spaces. So the columns go on the outer perimeter. We don't want any columns in the corners here because that's our view out. So what's left is the third points. So this gives us our columns, and then we're going to span across with these big girders, and we're going to span this way with our edge beams. And these are going to come across here and then cantilever. Come across here and cantilever. And cantilevers can get thinner as they go outward because as you move out, they have less to carry. So now we've got our structure for one of these pavilions. Now, we've got three other things we've got to do. One is we have to get in and out. Two is there's a fire stair here. We need a second means of egress. In case there's a fire right here, we can't get to this stair, we need this other stair. And we've got to bring in air. This is where the air comes in, comes down, and we got to exhaust air. We'll do that here. So, we get these guys. We don't want these in the middle because we want this open, flexible space. We don't want it in the corners, that's our view. This is what's left. So we've now arrived at this pavilion with these bump, 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 bump things on it. Totally through a series of logical steps, not by arbitrarily just putting bumps on the building. Now we've got a couple more things. We need our first means of egress, passenger elevator, freight elevator, toilets, storage rooms, intake, vertical ducts. Oh, I'm sorry. Before that, we got three of these. Okay, but they all need to share this stuff. So now we've got these three guys clustered around this. Kahn calls this servant spaces, and these are servant spaces. This, and these are served spaces. So the served spaces are the main functional spaces of the building. The servant spaces are corridors, stairs, elevators, etc. Now, we've got to hook up to the biology building that he does next, and hook up to the biology lab that he does next, and hook up to the medical school. So now, here's the whole thing. So we've arrived at this through these logical steps. Now, there's one, just as an interesting backdrop, Kahn explored some various ideas before arriving at the final form of the building. He had these structures in this arch form. And then he said, you know what, if this is exhaust, this lab is exhausted, exhaust air. This has to carry exhaust air for 3 floors, 3 or 4 floors, so it's got to be more. This has to carry exhaust air for all 7 floors, so it's got to be even more. So this would get thicker as it went up. And then he said, it's just too much. And then for a while he said, let's have big exhaust fans on the top of these things. So he had these big hoods. You see these in industrial buildings. And he ended up not doing that. Here's a drawing with this thing stepped out. So there are many earlier versions. If you get into studying this building in detail, you can find the early studies, but it then ends up with this. So here's the structure we were looking at. And Now I'm going to throw out some sexy terms. This building is precast, pre-stressed, post-tension. So, what does precast mean? So rather than building forms on the site and pouring the concrete there, you can get a higher quality concrete if you pour it in a factory under controlled conditions. You have vibrating beds to make it very dense, stuff like that. Pre-stressed means what? So there are rebars in the concrete. In pre-stressed, which you can't do very well on site, it's getting done in a factory. You tension the rebars, then pour the concrete. Once it sets, you let go. If you tension the lower rebars, it's going to, as they come back, it's going to bow the concrete up and gives it a head start against the downward pressure. So if you see a parking garage with big spans, those are probably pre-stressed. And finally, post-tension is rebars you put in tension after you put the building together. We'll see that in a minute. So here is our typical floor, and here are our precast beams, precast columns, and they are put in one floor at a time. After this floor is done, they're going to put another column on top of here. So let's just, so here we put in our columns, one floor. We put in our big girders spanning across. And now we've got to make the girder going this way, and this is in 3 pieces, 1, 2, 3. Now, it can't work structurally if it's in pieces, so we're going to look in a minute how that's done. Here are 2 of the 3 pieces. This one is this guy, it's continuous. This is one in pieces. These are then dropped in. So where have we seen a building made out of precast concrete members? You can give me an example.
Here.
Pardon?
Here.
Yeah, let's take a field trip. This is the kind of field trip I like. How many people have had studio with Donald Conlon? Anybody? He goes up to Yale where, sees it. Excuse me, did you sign in? Okay, so this thing's put together like giant Lego blocks. Here's our edge beam. Thanks. And there's 2 separate systems. One is the structure we're looking at here, and then these tubes or towers, this for air, this for stair. When it has this cut out in it, that's stairs. I don't know why, but that's what he does. This is poured in place concrete with brick veneer. So 2 totally different systems next to each other. Now, he goes one step further and he drops these little X things in here. And that turned out to be a problem. He realized he shouldn't have done that. Things are changing in the building, and the next wing of the building that we're not looking at, he leaves these out. Okay, now you put formwork under here and just pour a slab on there. And that's your floor, and it's going to lock everything together. And you can see, if we look close, that for these guys, let's see here, that right here, there's a little shelf here. So this thing sits on there, and that holds it together until it gets locked up. I'm going to show you how it gets locked up. So, in addition, Kahn wants the structure to, okay, typically what you do in a building at this point is you put in a hung ceiling. And above that hung ceiling is the structure and all the pipes, ducts, electrical lines, etc. Kahn doesn't want to do that. He wants you to see what I just explained. And this provides an organizing, the structure is organizing of the space as well as holding up the floor. Now, let's just stay on this a minute. The mechanical contractor freaked. He says, "What? This is all going to be exposed? I got to make it all neat." And it's going to present a problem. We'll talk about it in a minute. Now, here we are before the biology building is added, biology lab. So here's the vertical columns in pieces, each one floor, and here's the edge beam. And as it cantilevers, it gets thinner as it goes out. So here's the edge beam, gets thinner as it goes out. It's got this little bump here to hold this X that should not be there. And here we see a column, it's 1 story. And then they'll put on the next one. Here is an edge beam being hoisted into place. These are columns, and reinforcing bars are going to get threaded through here and tightened up. I'll see that in a minute. So this stuff comes with holes in it for the rebars. Here we see a column 1 story at the entrance. And then you see these loops sticking up. When we pour our floor slab, that's going to lock the poured-in-place slab to these beams. Here is the column from the floor below. This is going to be put on top of that, and then rebars will be threaded through these holes and screwed into these joints. Here we see columns going into place. Again, we see that's one of these. This is the poured in place of, in this case, the central unit to which the pavilions are come off of. Now, here's the post-tension. We have this in 3 pieces. Here are 2 of them. There's no way that's going to work. I mean, if you have a beam like this and it's in pieces, it's going to just collapse. But this is now putting the bottom in tension. The tension is handled not by the concrete, but by the steel. And so what has to be continuous here is not the concrete, but the steel reinforcing. So after this is assembled and it's held up by scaffolding, we then thread rebars through the holes that are cast in there. And these rebars are threaded, and we put nuts on them and spin the nuts down with these hydraulic wrenches, like the thing they use when they change the tire on your car at a gas station. So it's using hydraulic to spin the lug nuts. That's what they're doing here. As those nuts spin down, they tighten the rebar and put it in tension. And you set the clutch on the jacks to start slipping when you get the tension you want. So precast, pre-stressed, and then this is the post-tension. Architects were coming from all over the world to see this go up. This was, it's already 50 years ago, so it was quite radical and adventurous for the time. It'd be like the birdcage Olympic Stadium for the Beijing Olympics. If you had an opportunity to see that under construction, you would have wanted to see that. So any architect who was coming to the United States would make a point of stopping in Philadelphia to see this under construction. Then you go over to see Venturi's Grand Restaurant, which we'll talk about in a few weeks. Now, here's an entrance. I said he leaves out the glass and brick down here, and this then becomes an entrance pavilion. Now, this is the stairs going in. I'm taking this, well, I didn't take the picture. This picture is taken from the other side, and the reason for that is just the lighting is better so you can see this. So imagine these stairs are here. Every time you go into the building, you come up these stairs and you look up, and the whole story that I just told you, you see. So Kahn liked to say, the man is a record of the making of the man. The building is a record of the making of the building. So this building is telling us how it's put together, the story I just told you. Now, obviously, a lot of people who are not architects are not going to comprehend all this. But Kahn feels that on a subconscious level, it'll be clear to you what's going on. And this is what architecture should do. It should have a clarity. And when we talk about Kahn's philosophy, there's a reason for this. In other words, it is communicating a deep principle about who and what we are, an architect's role in that. Now, while we're at it, you'll notice when we look here, this is a Varandale. It's not a solid beam, but a Varandale. You can tell me what a Varandale is. A Varandale is like a truss, except it does not have diagonals. So in a truss, you have an upper chord, a lower chord, and then the webbing in between, and they are diagonal. In a Varandale, it's the exact same thing, except they're just vertical. And the structure works differently because of that, but what that means that there's this lower chord and upper chord, a space in between. That's where Kahn can run all the mechanical. So we can see that space where the mechanical runs. See all these holes here, here, here. All the pipes and ducts can run through there. So we see these holes here. Pipes and ducts can run through there. There aren't any in the entrance, but there are up there. Now, in mechanical is important in any building. In a laboratory, mechanical is heating, ventilating, air conditioning, plumbing. So it's the air ducts, the compressors for the air conditioning, the fans for the moving the air around, the electrical wires, the plumbing. HVAC or mechanical in a laboratory is half the budget, half the square footage, and half the cubic footage. In other words, it's hugely important. So we saw Mies in the Seagram building hiding all that in the center. And there are reasons for that. You don't want the mechanical out where the light is, where the windows are. You want the people out there. Put the elevator in the center. But Kahn is very engaged with this mechanical, and he's thinking, this is half the building. I don't want to hide it. It is as important to express the mechanical as it is to express the structure. And so the building told us how the structure worked. Now it's going to tell us how it breathes. This building is a diagram of its breathing process. So here, back of the building, is a botanical garden. So there are trees, there's a pond, there's different important species for the biologists. So there's a garden here. So this nice clean air is drawn into the building here through what Kahn calls nostrils, comes up these tubes, or towers, into this big space up here where there are huge fans and compressors. It then goes down and then into each pavilion. It's then used up, we breathe it, or we contaminate it with some experiment we're doing, and it's then exhausted out, high up, away from everybody, into the air. So in, up, down, across, and out. So the building is a diagram of its breathing. Again, if this is solid, it's air ducts. If it's got these fins, it's stairs. So here's the, this diagram is not showing these towers on the back, but comes up the towers in the back into this big mechanical room. Then it comes out, goes down here, and then into each laboratory, and then is exhausted out and up through here. So, this is a diagram of how the building's made and how it works, and expressive of Kahn's philosophy of science. Now, I just told you a wonderful story. And this is one of the most important and most respected buildings of the 20th century. And it is, Kahn's a very didactic architect. Who could tell me what didactic means? Teaching. So the building is not only supposed to be a good building, it's supposed to explain to us how architecture should be. Okay, having said all that, there were some problems with this building. And they're very famous, they're very well studied, very well understood. A major sociologist did a study of it, but we all knew what the problems were very quickly. So the problems are as follows. First problem is, the scientists look at, again, we're going to ignore this and just look at this part. Scientists look at these three pavilions and say, you know what? I've got half my team in here and half my team in here, and I'm running out, back and forth, trying to coordinate things. Why couldn't these three pavilions have just been one continuous space 3 times as big? Now, Kahn's defense is nobody told him that. And the reason for that is interesting. We've had major renovations in Higgins Hall. We faculty are not allowed to communicate with the architect. Only buildings and grounds can communicate with the architect. And so what I just described on the part of the scientist never got through to the architect. He was only communicating with buildings and grounds. You can, on the one hand, that's pretty stupid. On the other hand, you've got 50 scientists all telling the architect something different. You can't allow that. So anyway, that's number one. Number two, we see how this structure gets thinner as it comes out because it's cantilevered and has less to carry as it goes out. Now, in good Miesian fashion, Kahn has brick here because it was required by fire code. If you have a fire here, it's going to break the glass, come out, and then go back in, break the glass up here and go back in and spread from floor to floor. If you have 2 feet of fireproof, fire-rated structure, that can't happen. So this is required in a building. Now, has anybody noticed something recently with apartment buildings in New York? They're floor-to-ceiling glass in a lot of them. In the old days, you couldn't do that. But now we have glass that is fire-rated. So you're allowed to have floor-to-ceiling glass. Anyway, so this is glass and this is glass. This allows sunlight to get far into the space, back into that red circle I showed you. And what's the problem with sunlight in a laboratory? Biology laboratory. It's going to hit my petri dish and kill all the bacteria and screw up my experiment. Light is really vicious stuff. You ever notice how books on a bookshelf, the spines get bleached by the light? We're going to talk about this when we get to Kahn's museums. It'll bleach out the paintings. So, in defense, the scientists put newspapers, aluminum foil, and manila file folders taped to the glass. Really embarrassing for an architect. Now, this has been solved. It was supposed to be all along. There is a fine mesh screen here that stops the diagonal direct sunlight, allows in the view. But that was problem number 2. Problem number 3. If we had a very tall ladder in here, and I went up to these light fixtures and I ran my hand on top of that light fixture, what would happen? Be black. There's dust settling up year after year. You know, maintenance doesn't dust up there. Okay, so the air is being moved by the air handling. It disturbs that dust, and it comes trickling down into my petri dish and screws up my experiment. So this might be a nice aesthetic effect for the architect, but the scientists say, why can't we have a hung ceiling here to protect us from that stuff? And in fact, some of the scientists were so unable to work in this building that down the walkway they built another building for them, which is totally undistinguished architecturally, but fulfills their needs. So, those are the 3 major criticisms of the medical towers. And we're going to see in Kahn's next building also a laboratory, the Salk Center, that Kahn addresses those 3 criticisms. So this is our medical towers. You get a similar but not deadly virus. You take the original virus, you weaken it, or you kill it. And then you make a vaccine that you inject into children. And the body recognizes, oh my God, that's polio, but it's not going to hurt you. It then mounts a defense of antibodies. And those antibodies remain, so that when the poliovirus does show up, your body deals with it immediately before it causes disease. So when you're a kid, you get vaccines for measles, mumps, polio, etc. So in the 1950s, the March of Dimes, which was the organization dealing with polio, there wasn't big government programs in those days, selected a young researcher, Jonas Salk, to develop a vaccine. He did It was tested in 1954, and it was like totally effective. And so that immediately, some months later, every kid in the country got vaccinated. And Salk became a cultural hero, a major figure. And he parlayed that position into developing a research center, which we know as the Salk Institute. He didn't want to be in a university because he'd have to teach, wanted to do research. Didn't want to be at a drug company because he'd have to pursue what's going to be profitable for the drug company. So he developed this independent institute. Now, the first major biography of Jonas Salk was just published a couple of weeks ago, so if you'd be interested, you can look into it. The author's been on C-SPAN books talking about it. You can look that up and watch the interview. So he's kind of on our mind, and he had a difficult career. There's a lot of fundraising involved. Very famously, he wanted the Salk Institute to be a beautiful place that would attract, it would be a center for a new approach to science. They would see science in interrelationship with the arts and humanities. He famously said, I want a place to which I would be proud to invite Picasso. And then he married Picasso's widow. So he got that close. So here he is on the cover of Time magazine. Here he is later in life, distinguished figure. And here he is with his architect, Louis Kahn. So he had, he or a colleague, I'm not sure which, had seen Kahn lecture about the medical towers. He contacted Kahn and he said, I want that building. Kahn said, you don't get that building. You get a building for you. Even though Salk Center is the same size as the medical towers, it's in a totally different environment. So Salk had gotten a piece of land just north of San Diego on the cliffs over the Pacific Ocean. So we look out from here this way, we're looking at the Pacific Ocean. Let's see. Now, originally, they envisioned these would be the labs, these would be housing for researchers. Here we have a baseball field, tennis courts. There would be meeting houses for conferences. So they envisioned a huge complex. They never raised the money for all that, so they got just this one building. This is in a later version, the scientist housing. This is the meeting house, conference center. This is the laboratory. Only this gets built. Now, what we have is they decide on two wings for the building facing a courtyard that they share. And let's go to those criticisms that I mentioned. And the total square footage of the building is the same as medical towers, but there's only a third as many of the research laboratory areas. So each one is 3 times as big. So this is 3 times as big as one of those pavilions and medical towers, exactly what the scientists there were asking for. Then, one more criticism of medical towers is it talked about how the scientists were going to go to the window on the periphery to work on their notes. Well, the lab space just took over the whole thing. There's no room to take notes. That's not the architect's fault, it's just that you always are bursting your building at the seams. So this is the lab. It's got the lab furniture, lab benches, etc. Here is the scientist offices, totally separate, so the lab cannot encroach on those spaces. So each scientist gets, or the fellows, get their own independent lab space. And you can see, we'll see more in a minute, there's a diagonal here. This is directing the view toward the ocean. This is mechanical, and that mechanical is going to feed down here. We'll see how in a minute. And then this is cafeteria and library and administrative offices, again with views toward the ocean. And then this is stairs, elevator, toilets. Boom, 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 boom. Just curious. How do you like that? Somebody's following me on Twitter. Jeez. So, this is the layout of the building, and this is the courtyard space in between. Very famously, Kahn invited a famous landscape architect, Mexican Luis Barragan, to design the gardens, and Luis Barragan said, just pave it and leave it as a reflection of the sky. So this is paved with travertine, but no planting.
How come the drawing had plants?
Pardon?
How come the drawing had plants in it?
Oh, because it's earlier, when they were planning to do that. Yeah,
The landscape architect suggested the travertine?
correct. And at one point, the buildings are going to be half as tall, and there would be two of these, each with its own courtyard, and then they decided to have only one and make it twice as tall. Here's the meeting house, we'll see that in a minute, never got built, and this is the housing, never built. Now, the housing was probably not a good idea. The meeting house would have been great. This would be an incredible conference center. But the housing, it's like you're a young scientist, you have a family, you have kids. You want to be in the suburban community where your kids can go out and bicycle and meet other kids, and you don't want to be in, like a monk in a monastery. So, here is one of these wings, and what we have is, here's the labs, and then these guys are right here. This is 1, 2, 3, 4 offices. They're views toward the ocean. Now, the lab space is alternating. Lab space, mechanical space, lab space, mechanical space, lab space, mechanical space. And so we have the columns, and then we have these monster verandas spanning across. They cantilever out, making a walkway outside this glass wall. So if you want to go from this lab to the lab down here, you walk along this cantilevered exterior walkway, which is fine because it never gets hotter than 80 degrees or cooler than 60 degrees. So it's the country's most perfect weather, San Diego, just north of San Diego in La Jolla, California. So here is lab space. The mechanical then threads through these verandas. You see all these pipes in here, pipes and ducts. Then we go out, walk along here, and then we go up a half a floor to get to my office. So the offices are a half floor off from the laboratories to keep them separate. And then back here is these things that have stairs, toilets, elevators. So, all that clear? Great. So here are two of our offices, and in between is sort of a deck space, outdoor space. Here are our walkways in the back and the front. Here's the lab space. Here's the mechanical space, so we see the verandales, and here it's showing it stuffed with the mechanical equipment. So here's the back of the building. This box has stairs, toilets, elevators, and here is lab space, mechanical space, lab space, mechanical space. And the lab space has floor-to-ceiling glass, and the mechanical space is surfaced with concrete. So, poured in place exposed concrete. And Kahn gives it proportions by where he positions the joints for the formwork. Now, we can just barely see it, but let's go back here. We see how this walkway, this is cantilevered out. So now, our section is taken through these offices, but there's spaces in between. And the sun would come down, but now the sun is blocked from getting into the laboratory by this overhang. So we've solved the problem of the offices getting overrun by the labs. They're in a separate pavilion. We solved the problem that this is not big enough. It's now 3 times as big. We solved the problem of the sunlight coming in by this overhang, which is shading the floor-to-ceiling glass wall. So those are the 3 major criticisms of the medical towers. He solves them. So here is a model showing planting in this courtyard, and here is what they did. It's just paved with travertine, which is a form of marble. Then there is a fountain here, and the water runs down these grooves to a big fountain here at the end. And here's our offices and library and cafeteria looking toward the ocean. So the cliffs go down, and then there's the ocean. And here we're approaching from here and to this courtyard. That approach is no longer there. There's a new additional wing of the building across here, built later. Now, these are the offices or studies. 1, 2, 3, 4 of them. This is a huge, expensive structure for 4 little offices. But that's architecture. So everything is poured in place exposed concrete. Why is it safe to use that in this case? As opposed to pre-pressed? Yeah. Specifically, it never freezes. So the danger to concrete is that it gets wet, water seeps in, it freezes, becomes ice, expands, cracks the concrete. Starts to erode it away. Never freezes here, never goes below 60 degrees. So that's just not going to be a problem. The concrete is quite beautiful. Then these panels in here are filled in with teak. What's special about teak wood?
It's really dense.
Very dense. So where do you typically use it? On the deck of a boat, right. And you don't varnish it. The teak wood is tougher than varnish. So it's so tough it can take the salt air of being exposed here. So here are 1, 2, 3, 4 offices, and then in here is just an area to hang out. And here we see mechanical floor, lab floor, mechanical floor, lab floor. And we see how this overhang is protecting us from the sun. And here is lab floor, mechanical floor, etc. Here we see the overhang, so this is protecting the glass from the sun. Glass doesn't mind the sun, but what's behind it doesn't want to be baked by the sun. Floor-to-ceiling glass curtains, just for privacy if you want to shut off your area, you don't need it for the sun. And here's this is a walkway along here, and then we go up half a level to get into our office. So here is a lab floor. You can't get this picture anymore. The thing is totally filled. I was there when one of the floors had not yet been occupied. So here's our columns, giant verandale above here. Here's our column. Here's the verandale. So verandale is very deep, and we can now run tubes, pipes through here, pipes, ducts, wires. We then have a ceiling, which is also a floor for this area. So if I need, say, chilled water at my lab desk down here, the engineers can go in here, run the pipes, and then drop them, boom, right down to my desk. They don't, if there was a hung ceiling, they'd have to go in there with ladders, stand on my desk, put a ladder on my desk, go up there to move things around. But they have their own world, totally independent. And they can put anything they want in here. Now this building, hopefully, will never be out of date. Because what goes out of date in a lab is totally new and more mechanical is needed. Well, at some point, if they want to renovate the entire building, they just rip all this out and put in all new mechanical. This isn't going to age. Take the furniture out, put in new furniture. This is concrete, glass. That's not going anywhere. You don't even have to repaint it. It's going to last forever. This is a chiller. That's going to be outdated. You want to throw that away. But you just take all the stuff out of here, throw it away, put in new pipes and ducts. You don't have to, the building, in a sense, lives forever. Hopefully, we'll see. It's 50 years old, and so far, so good. And now, we can accumulate dust in here. There's a floor. It's not going to come down and filter into my work. All the mechanical is up here in its own world. Here is the courtyard, band of water running down, and very elaborate fountains down there. We'll see in a minute. Here's the water. So we look out to the ocean. Here are our angled concrete walls pointing the view of the offices in that direction. And here, this is a 4-story blank concrete wall. But Kahn is giving it scale by where he puts the joints for the formwork. Over 300 drawings were made just for how to do the formwork. Usually you'd say to the contractor, just build formwork, whatever you want, because we're going to cover it up with brick or whatever, with a veneer. No veneer here, this is exposed. So Kahn's very deliberately designing where this formwork goes. And that's what's giving it its scale and proportions. Now, here's the courtyard. Here's the walkways. I'm sorry. Here is the studies for the scientists. Here is the walkways. Here's the labs. And here is those bumps on the back that have the stairs, toilets, and elevators. There's a notion in Hinduism called the 5 sheaths, like a sheath for a knife. And they are, the outer sheath is body. So it's body, mind, society, culture, spirit. The outer sheath is body, but there's no, a worm has a body. It's just meat. There's no mind there. That's the stairs and toilets. Then there's the intelligent activity of the building taking place in the laboratories. That's mind. Then there is, you go out of the lab on those walkways and encounter other scientists. That's society. You then go to your individual office and render your observations into theory. That's culture. And then the courtyard is like a cathedral without a ceiling. That's spirit. So, the complex is a mandala, body, mind, society, culture, spirit. Now, Kahn did not say that, it's my observation. Now, something interesting. When we get to theory, we're going to talk about, Kahn refers to something he calls form and design. Form is the underlying organization of a building and its meaning system. Design is the particular way you carry it out and the materials you use. The medical towers and Salk have identical forms. They have different designs. So here is the flexible place for the labs in medical towers. Here it is in Salk. Here is the place for the scientists to go work on the theories. Here it is in Salk. Both have all these elements, they're just arranged totally different. So the elements, which are the underlying organization of the building or its form, are the same. The design is different. Here are mechanical, stairs, elevators. Here's stairs, elevators, toilets. Here is the shared mechanical space with the blowers, the venting, etc., which is then piped into each lab. Here they are at Salk, and they then run down the length of this in that upper mechanical area. So, different designs, identical forms. Now, very briefly, a very important and interesting and beautiful building that was never built is the Salk Meeting House. Here, Kahn develops his double wall. So this inner wall here would be glass, and then this outer wall is a sculpted form, and it modulates the light coming in before it gets to the interior. And he's now been revisiting Roman architecture. He's turned on by form. So these are circles inside of squares, squares inside of circles, same idea. He's got an amphitheater right out of a Roman theater. And so here we see this rich playing with Roman forms in this building that was never built. And here's a model of it. And here is, people have been building models recently, so here's some more models I found online. Here's Kahn's original drawing. Here, somebody did a book of Kahn's unbuilt works on the computer. And I think if you were to redo it today, it would look even more realistic. So here's the stuff looking realistic because it's built in the computer.